Hi, everyone, and thank you for joining us for this month's Rancher Online Meetup. This is Shannon Williams from Rancher, and it's great to see so many people here for today's event. Looks like we are going to have a fantastic crowd. It seems like this event may be one of our most popular yet. Today we're going to be talking about storage for containers and cloud-native deployments, and we've got a great group of presenters here to talk. Just as a quick introduction for myself, I'm Shannon. I host this with Darren every month. I'm actually calling in today from Berlin, where I'm here for, oh my gosh, it's my hotel phone, for KubeCon, a conference here in Berlin. Unplug that, there we go. And I'm joined by my co-founder here at Rancher, Will Chan. Will Chan is our VP of Engineering. Will, can you say hello?
Yeah, hey everyone.
Usually Darren would be joining us, but he's actually on a plane flying out here to Berlin for the conference. So we're lucky to have Will. Will runs all of our engineering team here at Rancher and has been with us from the beginning. He's one of the founders of the company. We're also joined by two guest speakers who are experts on container storage. The first person who's going to be presenting is Bjorn Quobyte from Quobyte. He's the co-founder there. Hi, Bjorn. How are you this afternoon?
Hey, Will. Thanks for the introduction and the invitation.
Excellent. Bjorn is actually from Berlin, which is where I am, but he's in California. And Gu Rao from Portworx is on the call. Gu is the CTO and co-founder of Portworx. Hey, Gu.
Hi, everybody. Thanks, Will, for having us, and looking forward to this.
All right, so we are going to dive in and get going. But for those of you who don't know, this event is something we host every month. It is really designed to be an online meetup, not a traditional sort of webinar where we present lots of slides and talk and don't listen. It's meant to give everyone a chance to ask questions, to go through a lot of focus on the more technical aspects of the implementations, and it means a number of things to us. We really focus on this every month because it allows users to get involved in the content and get involved in the story. So a couple things to think about because of that. We don't really have a stop time. We start now. We almost always go for more than an hour. Sometimes we've gone for more than 2 hours. So we won't be done on time, whatever that means. We do record the entire session. We post it on YouTube when we're done. So you can leave comfortably and come back and watch some piece that maybe you wanted to see, but you had to go back to some other meeting. Questions are always welcome, and there's a questions panel here in the GoToWebinar console that you can use to ask questions. I'll be reviewing that as we're going. I'll ask the questions of the presenters that you're asking. Sometimes we'll answer them, in writing if we can just kind of fire off a quick answer about something. But we'll try to get your questions out in front of people. We'll be demoing as much as possible, so we'll try to demo all the solutions. Because of that, things sometimes break, we get latency, we have demos that blow up, so be patient. Don't, because we focus on more of a hands-on discussion and demonstration of these things, we see, we see all sorts of demos failing as we go. The way we do get together, though, is on Twitter. So if you're on Twitter, send us a picture of yourself, hashtag it with Rancher Meetup. You can see a lot of people on there. You can have a secondary conversation there with other people who are attending today's session and ask questions and chat about their, what you think of what's going on. So please join the conversation on Twitter. Use the questions tab here and ask your questions, and we should have a great meetup today. Okay, so we're going to go through really 5 quick sections. I'm just going to do a couple-minute overview of Rancher for those of you who are new to Rancher, explain what it is, what our company does, what the open source project's all about. Then Will Chan is going to dive into kind of a high-level overview of storage concepts and data persistence in Rancher and, in Kubernetes and in containers and Docker. We'll talk just a little bit about what the current state of the art is, how people are using different things in Rancher to persist data. Then Bjorn is going to dive into Quobyte, and he's going to walk through and talk about Quobyte and their technology. Gu is then going to go and talk about Portworx and explain what they do. And finally, we'll finish up with just kind of quick updates on the latest Rancher releases and answer any questions. just keep in mind as you're asking questions, if your question is sort of more general or not related to the exact topic we're talking about, I may sort of push it to the back and answer it a little bit later when we have some more time, so I don't interrupt the presenter. But we will get to everything as long as you stick around. We'll certainly answer every question that's out there. Okay, so just a quick introduction to Rancher for those of you who don't know us. Rancher is an open source software company based in California. We have two main products that we develop and build. One is Rancher, which is an open source platform for running your containers. It's a container management platform. And the other is Rancher OS, which is a tiny 50 meg OS distribution built to run Docker containers specifically. It runs Docker as the PID1 daemon in the OS. Rancher itself has become an incredibly popular project. It's used by tens of thousands of organizations to manage their containers. It makes it incredibly easy to spin up and deploy environments of all types. It makes it easy to actually manage the applications in production, manage application catalogs, deploy and upgrade the lifecycle of your containers. And what makes it so popular is it ties together all of the orchestration necessary to run your environment at both the infrastructure and the container management level, meaning you can deploy your environments, you can deploy multiple environments, you can choose who can access those environments, and Rancher will deploy all of the necessary infrastructure services for your environment, whether that's the storage tools we'll talk about today, or it's overlay networks, or it's DNS services, or load balancers, or security tools. And we do all of that across multiple orchestrators. So we let you come in and choose whether you want to use Kubernetes, for our own cattle platform, Docker Swarm, Mesos, whatever orchestration you want to use. And then allow users to either come in, deploy their own clusters, or deploy applications against existing clusters very easily. So it's really geared to the complete lifecycle management of containerized applications running anywhere, in the data center, on your private cloud, and VMware, or running out in the public cloud, really any cloud, anywhere. As long as we can get a Linux host with an IP address, and now even a Windows machine, you can deploy Windows environments, you can set up and start deploying a Rancher environment. So if you haven't tried it already, we certainly recommend give it a download and get involved. You can also visit try.rancher.com and access a hosted open version that you can just play with. The entire Rancher platform and Rancher OS are both 100% open source projects. So everything we do is done in the open, and you can participate either as a user or a contributor on GitHub. Okay, so that was quick. We're going to dive in now to today's main topic, and we're going to talk about different storage options and best practices for persistent data. So I want to start by turning it over to Will Chan, and Will's going to take us through an overview of storage and explaining the best practices today for running storage in Rancher and in container deployments. Will, you want to take it away?
Yep, can you hear me?
I can hear you just fine.
Perfect. Okay, since we have two great guest speakers today, I wanted to give you guys a kind of an overview about a little bit about Docker Volume plugins. I think a lot of you guys already know that, and then tell you guys how it works and how Rancher plays a role in managing these plugins. So to give you a little quick history, since Docker 1.8, which was released in August 2015, Docker released the whole concept of Docker Volume plugins, and since then, a lot of plugins have been released. It's really to address the issue of moving from stateless containers to more stateful ones, things like MySQL, etcd, apps like that requires some type of persistence data. So you'll see, there's a lot of vendors out there, NetApp, EMC, including our two guests via Quobyte, Portworx. There's lots of cloud providers out there. And there are actually other frameworks as well, RexRay, Open Storage, that is another plugin framework to Docker Volume plugins. So a lot of there already exists today. But while there's so many of these things, the problem today is you still have to download it, you still have to install it, you still have to also manage it. And that's really where Rancher plays. If you can switch the slide for me, Shannon. Yeah, and so this is where Rancher plays and how we manage his volume plugins for you. So it's a lot of text. If I go through each individual one, number one, what we do is we assist with the distribution aspect of it. As I said before, with these Docker Volume plugins today, you still have to download, you still have to install every single host. As you add more hosts to your Docker clusters, you still have to do it somehow yourself manually, and that's where Rancher plays a role today, where as you add hosts to these Rancher environments, we'll automatically place these drivers or these volume plugins for you, so you don't have to worry about that. So along with that, the next thing we do is, of course, version management and upgrades of these drivers itself. As new things changes, you may or may not know, with Rancher today, we'll inform you that there are certain new versions of these plugins available, and again, with a click of a button, we'll automatically push all these changes to every single host that requires this updated plugin. So that's the next thing we do. With that, lifecycle management as well, since Rancher provides basic health checks. If things fail, if these plugins die, we'll detect them, we'll automatically restart them, so hopefully you don't have to manage that yourself as well. And the last thing we do is what we call plugin container scheduling. Of course, depending on where you have these Docker plugins, some hosts may have it, some may not. We'll make sure that when you schedule these containers, we'll place these containers on a host that actually has the plugin, so you can talk to your backend storage. Next slide for me. And so really, how is this really done in Rancher today? It really leverages our Rancher catalog. For those of you that have seen it or played with Rancher today, we do have a catalog feature out there today which has many different apps that's already written for Docker or written as Docker Compose templates. And we leverage that basically for our version and upgrades and distribution of these Docker Volume plugins, and hopefully you'll see some of that in the demo today, where you can create an environment, you can add your host, and you can select the Docker Volume plugin that you want to install on all your hosts. And of course, the only thing that we do require for the distribution, because we run it as Docker Compose template, is the fact that these plugins has to be Dockerized and essentially run as a Docker container. Once that is up and running, and our storage vendor or partners or anyone essentially can upload these catalog templates into Rancher, and we'll make it basically available to everyone else that's out there today. And then, of course, the last thing that Rancher offers is some basic container scheduling, as I said before. Since we know where these plugins are actually placed on, we can be smart about that and make sure that any containers that require these plugins or requires the volume that leverages these are placed in the correct host. Next slide. And so this is my final slide today, or a couple more slides, sorry. So this is to show you kind of the catalog that we have. I took a quick screenshot of what we have today. You'll see, Meetup is part of there. I think you'll probably end up seeing Portworx and Quobyte as well. I show you some of the RexRay, and of course some of the Rancher supported ones that come out of the box, including EBS, EFS, and NFS as well. EBS and EFS right now are experimental, but we do plan on GAing this in 1.6, which should be coming out end of April. And one more, Shannon, hopefully.
Well, yeah, there's a couple more, but just a question came in. So we're talking about two different kinds of storage here. Obviously, we're talking about storage that's, in the case of something like NetApp, you're seeing SolidFire as well as, traditional SAN. You're talking about EBS volumes in Amazon or traditional NFS. So it feels like there's lots of different approaches to storage. The question was kind of, do we support both overlay sort of deployed storage or just storage that comes like traditional NFS services? You can maybe talk to that, but sort of explain the difference between those and how you can either implement and deploy a storage platform, or you can just connect to an existing storage platform, and how when you might choose one versus the other.
Actually, do you know my last slide? Do you have my final slide that's up here? Maybe I can talk with it more.
Sure.
Should be one more slide in here. No, there's one more. Oh, this one. There you go. Perfect. Okay. So,
sure.
Yeah. So, I guess to talk about to answer this question, we essentially support them all. Rancher does not implement the storage solution. We're not a storage implementer, so to speak, right? We're here to actually manage the Docker Volume plugins, which actually connects to these various storage options you may have. So on one end, you have these storage vendors, Quobyte, and Portworx, the two guest speakers we have today, will explain their solution offerings. One of them is, I believe, is a block storage. The other one's a file system. NetApps, of course, has as well. EMCs has another one where you can deploy the scale-out solution, and RexRay is actually kind of the framework which allows you to connect to even more storage option itself. Then Rancher, of course, has some basic supported Docker Volume plugins. The most commonly used one right now is NFS. It's the easiest to get up and running without having to install anything particular. Most Linux distro already have some type of NFS server for you to install and run. EBS, ENFS, of course, are strictly tied to Amazon. So if you have something, if your containers, most of your workloads are already in Amazon today, that of course is up to you to leverage those solutions for you. And what these, so for example, for EBS, the EBS plugin, for example, is the reason why you would use this plugin is for EBS. Once you, let's say you start a container on host A, and you create a volume that leverage your EBS volume. Of course, you can leverage the EBS options of backup snapshots, whatever in the backend, however you want to persist that data. But the key thing here is, let's say the host goes down, or you want to move this container from one host A to host B. The plugin itself will actually make the correct API calls in Amazon today, and will detach that EBS volume, reattach to the host, so that from your perspective, you didn't have to do anything. We automatically move the EBS volume from one host to another for you automatically. And so things like EBS, or even if you look at the right, there's a lot of, we don't have these today in our catalog, but a lot of the providers, some of the major cloud providers, Azure, DigitalOcean, GC, Amazon, already have some type of Docker Volume plugins that connect to their native cloud storage options. And so if you already are running on these cloud, you may want to leverage these things. It's actually totally up to you. But again, we don't implement these storage options. We just manage the plugins that allow you to talk to these storage options. And then for certain options like EBS or EFS, we do a little bit more. And rather than you manually moving these EBS volumes from one host to another, we'll do that for you as part of the plugin itself, so you don't have to do that. And then, of course, the storage vendors, if you happen to have, there's several options, right? If you can go very expensive, you can go with NetApp, you can go with whatever EMC's storage solutions out there. If you already have that today, if you want to leverage those things, you're more than welcome to do so. But we also have these overlay or soft-defined ones like Portworx, like Quobyte, where you can leverage your existing local disks out there today, and it can essentially create a storage solution for you, so you don't have to buy very expensive SANs or storage solutions out there. So it's actually really up to you. I would say that if you're a Rancher user today, the three most common usage we have today, of course, is EBS, EFS, and NFS. It's just easier to use. NFS by far is the easiest. It's a technology that's been out there for a very long time. But certainly there are more viable options, and hopefully with our two guest speakers today, they'll give you more options on what you could choose.
Well, the big thing too, obviously, is that when you start talking about things like EBS and EFS, you're very much tied into the Amazon ecosystem. When you talk about NFS, you're tied to a specific NFS. Or what's so exciting about some of the things we're going to talk about today is what you're seeing is the potential for storage that can be overlaid anywhere and can be as portable as your containers. I think that's what's so transformative. There's a couple questions that came in. Darren Ratcliffe asked, he said, so how does this relate to Kubernetes and persistent volumes, or is this different? You want to talk a little bit about that?
Yeah, actually, I missed a little bit of that. I didn't really go too much into that simply because our two guests were going to talk about Docker plugins, but Kubernetes we also do as well. So persistent volume Kubernetes is a little bit different. Kubernetes allows you to upstream the persistent volume driver. So many of our vendors today, even I believe the two we have today, probably already have a persistent volume driver that they've upstreamed into the Kubernetes distro, where each version of Kubernetes that gets launched, it's actually already packaged as part of that. So Rancher does not have to do that for you, or at least what we do for Docker Volume plugins. So Kubernetes itself already has a couple of things. They do distribution, they do lifecycle management for you for these PV drivers. And as you add hosts to the Kubernetes cluster, they automatically ship the these the PV drivers right into the host, so you theoretically don't even have to manage that yourself. The flex volume is just another version of the PV drivers where if you do have flex volume plugins, that's where Rancher could play a role in it, because I don't believe you can, and I could be wrong. I'm not sure you can upload the flex volume drivers into Kubernetes itself. It's just another way for you to attach other storage option that may not be part of the distro. In that case, this is something where you could put this right into Rancher itself and have Rancher automatically distribute those flex volume drivers for you automatically. So yeah, so hopefully that answers that question.
Yeah. Another question that came in was, with a couple questions about EBS. Ian asked, he said, can you scale up containers using the Rancher EBS volumes? He's had some errors when attempting to do so in the past. So can you talk about that a little bit?
The short answer is, because Docker Volume Plugins has a way for you to pass any options. We don't do it. I don't believe we do it today, but through the options parameter, we might be able to do it. And I'm not even sure you could do it dynamic in this only prompt, because options are probably something you have to do on startup. If Docker Volume Plugins, I don't think it has an option. I don't think we can. The only time we could do it is during the creation of the plugin, or the start of the plugin itself. So at that time, you might be able to select if there's an option to anything through the API. We could do it at that moment. But dynamic scaling, right now we probably don't do it, because we're really just implementing the Docker Volume plugin. So if it doesn't allow you to do that, we won't be able to do it for you. But certainly the Docker Volume plugin has a way for you to attach, detach, mount, unmount. Those things we can implement for you automatically. If there's no scale option, I don't think there is one. I don't think we could do that. We might be able to do more custom ones through Rancher specifically. We can probably offer that through Rancher API. It is possible to do, but that's not in the current implementation today.
Thanks, Will. There's another question from Gregory. He said, currently we can only select a single, quote unquote, back office driver per container in Rancher, EVS or EFS. Is it possible to select different plugins in the same environment? Will it be possible to select different drivers on a single container? So can you have multiple drivers for a container, for an environment, for stack? I mean, can you just chat about that?
Well, you can certainly have multiple plugins. So you can enable EBS, EFS, NFS, or even Portworx and Quobyte if you choose to. They just come into the way you specify is when you create the volume or you attach a volume, you just have to specify the driver name to it, and that's it. So you can certainly have multiple of these plugins distributed, managed for you, and then how you use it is selecting or the driver that you want to use for your volume. Now, multiple drivers per container, I think maybe if Docker allows you to do it, and they may, then yes. I have not looked at the API myself recently, but if Docker allows you to say for volume 1 you can select driver A, volume 2 select driver B, then certainly yes, it should work. Theoretically, it should just work.
There was another question Davis Clark asked, and we'll probably have to make this one of the last questions before we get moving. I'll certainly get back to these other ones. But Davis said, does Rancher have any concept of storage bandwidth saturation on a host-by-host level in situations where you may be running lots of containers with EBS volumes?
You mean something like if you mean by some kind of quality of service? Again, if let's say you use EBS, and EBS has an option in the API to determine QoS or any type of options available, we can certainly pass that. Even though we may not support it today, that can be, we can certainly implement something with the driver, the volume plugin options, pass that in, and at that moment in time, when we instantiate that plugin or start it, we can certainly make that appropriate Amazon API call to enable the option. So if it's not there today, I don't think it'd be very hard. The only thing we can't do is change it on the fly with the previous questions of dynamically scaling. That is probably much harder to do. But certainly on startup, if there's an option for us to do it, and even if we may not have it today, we can certainly make that available. I don't think it'd be very hard to do.
And this is Gu. I can talk a little bit about that during my segment, how with Rancher we can support dynamic scaling and dynamic IOPS throttling. So I can certainly address that in my section.
Awesome.
Awesome. All right. Well, let's get moving, guys. I know I knew this was going to be a big topic. That's why we have so many registrations for this. this thing. So we're gonna keep going and get through a lot. But right now I want to hand it over to Bjorn. Bjorn, are you ready to go?
Yep, definitely.
Okay, I'm going to make you the presenter. Will, thank you very much for going through all that. It was great. It was exactly what we wanted to do to kick it off. Everyone who has all the questions, I'm going to try and answer some as we're going in the chat, but we'll certainly be addressing some more as we go along. And stick around. We will not ignore your questions. All right, Bjorn, can you share your screen? There we go. I can see it. You're up and running.
Okay, perfect. Just a quick intro of myself. I'm one of the co-founders at Quobyte. We started the ExtremeFS project, so that's Felix, Jan, and me, my co-founders. We started in 2006. It was a research project focused on fault tolerance and scalability for a distributed file system. Then, after finishing our PhDs, Felix and I worked for Google in Zurich and New York. And in 2013, we decided that we wanted to bring what we learned with ExtremeFS and the operational scalability that we saw at Google. We wanted to bring that to the enterprise and started Quobyte. So let me start with what the Google style infrastructure actually is. And most of the stuff I'm saying here, or basically everything, is actually public knowledge. So Google has published the papers around that. There's a book by Urs Hölzle about how they run the data center. So you can actually get the details online about what I'm saying here. So basically, on the foundation layer, we have the data center, and the Google-style data center, or warehouse-scale data center, is kind of a war zone. So constantly there's hardware failing, there's admins that just go in and take a server offline, and they don't care what is running on those servers. Nobody cares if a server or a disk crashes. They will be replaced on a maintenance schedule, maybe in a month from now. So this is what I meant with kind of a war zone. And then the responsibility to deal with those kind of failures is actually shifted to the upper layers, to the software infrastructure. And so the layer on top of that is first Linux plus containers for isolation of workloads, and in the end to do multi-tenancy. And then Borg. Borg is Google's cluster scheduler that runs the applications and distributes them across the cluster, restarts services if they went down, if they crashed, or if the machine went down. And with Kubernetes, Google has made this available to everyone, something that is very similar to Borg. And then on top of this layer, you have the Google file system, which offers replication of data and erasure coding to actually provide data redundancy across multiple machines, so that if a machine fails, the applications that run on the Google file system actually don't notice that. So what the Google file system does is provide all applications with a safe and reliable storage system. So a big topic is Google-style infrastructure for everyone else, and since you're all interested in containers, I guess that is part of the idea behind that. A lot of people say, okay, I'm not Google, I don't have this scale. But a lot of the things that Google has make sense even if you just have 4 machines in your own data center, or if you're running AWS, because you want this agility that you can quickly allocate resources instead of, for example, ordering custom hardware, waiting until it's delivered. And most importantly, the fault tolerance is important, even if you just have 4 machines. Getting this reliability in software cuts down costs significantly and allows you to run all kinds of applications on commodity hardware. And commodity hardware is available today. So you can get that from the big vendors, you can get white box, or you can even get the OCP-style servers where Facebook published the specifications. You can actually run the same hardware that Google and Facebook run. Then you have the containers available, and with Kubernetes you have you also have the cluster manager, similar to what Google has. But of course, storage is a big question mark. And Google has a completely custom-built stack on top of that. So their applications are designed for a special kind of file system that does append only and write once workloads. So this is not directly applicable to what everyone else has, which is POSIX or NFS, and then legacy applications, which could mean, for example, MySQL. And then even the cloud-native applications, if you think about things like Cassandra or Zookeeper, there's a very interesting paper from the FAST workshop where the scientists demonstrated that even the cloud-native applications react horribly if the storage is not perfect and there's bit flips and so on. So even those applications actually require a reliable storage infrastructure. And this is where Quobyte comes in. So we have developed what we call data center file system. So on the bottom layer, you have the commodity hardware, and with commodity, we really mean nothing special, like no RAID controllers, no NVRAM, no special devices for journaling. On top of that, you run Linux, and then the Quobyte software, which runs in userland, you can either run on Linux itself or in containers. And then Quobyte gives you a scale-out shared POSIX file system that you can mount, for example, in all of your containers, and I'll go into details a bit later. And then on top of that, you can run traditional applications like MySQL, you can run your LAMP stack, Cassandra, Elasticsearch, and so on. And the core of our data center file system is really the reliability in software. So storage, if you want to run it as just another application on your cluster, your storage must be cattled to stay with a Rancher terminology. And in order to achieve that, we implemented split brain safe replication. So you can either replicate your data synchronously across 3 machines, or you can choose erasure coding. And again, we have built in end-to-end checksums, and that's one of the most important things we learned. You cannot trust the hardware. We had so many things where the drivers for network cards, RAID controllers, firmware for flash drives was broken and corrupted the data. The end-to-end checksums, really from the moment we get the data from the operating system until you get it back, make sure that you get the data back that you put in. And because of that, fault tolerance, you can ignore broken or slow drives, broken servers, crashing servers, broken network cards, and so on. So we take care of that for you, and your applications see a nice, reliable storage layer, and you don't need to care about service dying. So if the cow drops dead, you don't care. Another aspect of a data center file system is that you have the linear scalability. So if you want to build a horizontal infrastructure like Google has, it's important that by adding servers, you actually increase the IOPS throughput and capacity without bottlenecks. So traditional setup, if you have, for example, hardware storage, you usually have a controller node that everyone talks to. If you have software solutions that have NFS gateways, some of the block stores, some of the object stores use that, you always have this bottleneck of the node, or exporter node, or controller. So what we did is, in our environment, the clients directly talk to all the storage servers in parallel, even if they operate on the same file or on the same volume. So you don't have a bottleneck, and you can run demanding throughput applications like big data analytics, video streaming, transcoding. You can run a LAMP stack with many nodes in parallel, or even high-performance computing applications. And if you think about a cluster where you run Quobyte on the same nodes as the compute, you can grow both in lockstep when you enlarge your cluster. Similarly, for horizontal storage infrastructure, you need to be able to run different types of workloads on the system. So we made sure that you can run high throughput on our system, but also low latency demanding IOPS applications like databases where you need high transaction count, or even small file workloads that you find in applications like EDA, 3D rendering, or particle simulation. And all of that with consistent latency. To give you an idea what you can expect from software storage, we did an evaluation on Packet.net, which is a bare metal cloud. And you can see here that the operations are all well below 500 microseconds. And those you can run against the file system in Quobyte. So you have a native file system driver for the major operating systems. But you can also use S3 and Hadoop, and they map to the same space. So file is an object and vice versa. One of the nice things of being a file system is that we have the context available. So we know the file name, the extension, which application created the file, when it was last accessed, and the age. And in Quobyte, you can use that to actually place each file individually. So instead of spreading it across the cluster based on a hash function, we have policies that you can configure and then decide, for example, that a file should be stored on hard drive or SSD, so tiering, and you can also move them between the tiers, or you can have quickly allocate pools for dedicated hardware, for example, to isolate a database performance workload. But you can also use that to do application-aware data placement, and I think this is where it becomes particularly interesting. So for example, with Cassandra, there's basically two types of files that Cassandra uses. The commit log, where each transaction is appended, and for that we would use replication to get the low transaction latency on high-end flash like NVMe or write optimized SSDs. And then for the bulk of your data that is created on compaction, that is stored in SS tables, and they are write once and then read only. So in Quobyte, you can use erasure coding to keep the storage blowup low, significantly lower than replication. And you can also use read optimized SSDs, which are much cheaper than NVMe or the write optimized. So in the end, you get through little configuration, you get very good dollars per IOPS for an application like Cassandra. Quobyte has integration with Kubernetes and Docker. So on Kubernetes, we have a persistent volume plugin that's part of 1.4 and newer, and allows you to have volumes that are global to your entire cluster, just visible to all the replicas of an application, or to a single container. And the plugin also does automatic volume provisioning, so you can use existing volumes, you can create new volumes, and because we're not a block store, the volumes don't have a fixed size, so you can set quotas on them and reconfigure the quotas at any time, so you don't need to resize them, for example. One thing that we added lately is a proper user ID mapping, and my colleague wrote a blog post about that. So we get the information from Quobyte about the user and then map all the I/O activity from that cluster, from that container to that user, so that the user IDs that come from inside the container that are meaningless to the outside world are actually mapped to something proper. On the Docker side, we have a volume plugin which you can get from GitHub, and you can get Quobyte itself from our website, and soon directly via the Rancher catalog. And you have a chance to talk to us directly at KubeCon, actually tomorrow in Berlin. We're also at NAV Show and at OpenStack Summit in Boston in May. And that's all from my side.
Thank you, Bjorn. That was great. I appreciate you going through that. There's a couple of questions that came in while you were talking that I'd love to see if you could address. One of the first one was kind of John asked about pricing. Is there anything you can share, about this about the product? How do you procure it? Is it open source, or any components of it open source? And if not, what's the price range? How do people buy it?
So we're a closed source solution. You can get basically a free test license that is unlimited in capacity from our website. And then pricing depends on usable capacity. And basically, you can get in touch with us, and then we'll discuss the details.
Okay. A couple other questions. Thomas Tolborg asked, he said, how about multi-site synchronous replication? What's the maximum distance between sites, latency level that is acceptable? Can you talk about that a bit?
Mm-hmm. So acceptable is up to 250 milliseconds, and we have tested with, on Amazon, for example, spread across the entire North American continent. So for throughput workloads, that's usually not a problem, and with so it's synchronous replication, so the question is really what kind of latencies can your applications tolerate?
Okay, there's another question from Ben Emmons, but before we get to that, I've seen two people, Skylar and Grant, come back and say that when they click the quobyte.com/get it, they're getting a 404 on that link. So I'm sure if you go to Quobyte's main page, you can maybe there's a mistype or something, but try that. Otherwise, I'm sure it's just a temporary thing. We'll be taken care of later, but just a little heads up there.
Yep.
And then there's a couple of questions a couple more. One is from James. He said, can you do a brief comparison with Ceph storage and kind of talk about how Ceph versus Quobyte are similar or dissimilar?
Yeah, so I think architecturally speaking, Ceph is an object store and uses consistent hashing to distribute the blocks of a file. In comparison to that, Quobyte has a policy-based placement, and that is done for each file individually, and you can move them between tiers and pools and so on. Then Quobyte has the file system layer. I know that CephFS is, I think they're out of beta, but Quobyte has some features in terms of performance, multi-tenancy. We have the ability to have a large number of volumes spread across hundreds of metadata servers if you need that. And then in general, what our customers find is that we have significantly better performance.
Great. There's 3 more questions that came in. Ben Emmons asked, how's the performance for large terabyte-sized files, such as scientific data sets?
So in throughput, it actually depends only on your network and what your disk spindles can deliver. So we have one customer that runs, I think, between 30 and 40 all hard drive Quobyte servers and gets 50 gigabytes per second. If you need double the capacity with or double the throughput with the linear scalability, you just double the servers. And you get 100 gigabytes per second. So for us, because we don't have a journal device and we preserve I/O patterns, it's actually very simple. You just look at the server, what kind of throughput does each server have, so network and hard drives, and then you multiply it by the number of servers. And then you check the network in between. So what can the network deliver to the clients?
Great. Another question, this one from Ethan Fremen. He said, does Quobyte feature snapshot or COW-like features?
No, not at the moment. Okay.
And another question was from Mike Phelps. He said, is encryption supported for Quobyte?
Address encryption, yeah. We work with local drives, and they can easily be encrypted with, for example, Linux looks, or if it's SSDs, they have AES encryption built in.
Excellent. Chris asked, how does Quobyte compare to iRods?
Okay, yeah, iRods would be on top of Quobyte. So iRods is metadata management and points to the actual storage. And then Quobyte is actually taking care of reliably storing your data, ensuring replication factors, dealing with broken drives, and so on. So Quobyte actually works on the hardware and does the storage.
That brings up another question that Luca just asked. He said, can he run it on top of AWS EBS?
Definitely. So if you run, we have customers running on AWS. In that case, you would disable our replication because you're using the elastic block storage for that. But you can deploy us basically on any cloud where we don't care about the hardware, so to speak.
2 more questions, lots of questions. This one is from, I'm probably going to butcher your name here, but Jana Kiraman, and he asked, what is the maximum scalable limit in horizontal, at the horizontal level? Like how wide can you go?
Theoretically and architecture-wise, that's unlimited because we don't have a central entity like a log service. We have tested several hundred nodes and thousands of clients. So basically, we have a background in high-performance computing ourselves, and have also some customers in the HPC space, and they tend to test at very large scale.
Okay. So there was another question from Jose Roberto, and he said, does the quota feature mentioned, or is the quota feature mentioned available in Rancher? And is the endpoint encryption or REST encryption also available running Quobyte on Rancher or within Rancher?
So we're working on the Rancher integration. I think today the quotas are not integrated, but it's fairly easy. So all our configuration is done via an API. And so it's updating, setting, or requesting quotas is just an API call to a REST API. So that's not a problem. And the encryption is basically done at the level when you create the actual storage devices. So that is independent of Rancher.
There was a question from Mikael, and he asked, does Quobyte have an HDFS interface?
Yes, we have a plugin that basically implements the HDFS interface and replaces HDFS.
Okay, and the last question is from Ronnie. He said, can everything we're talking about on Quobyte run inside a container?
Yes, it can. Client and the server component can run inside a container. For the server component, you'd have to map the storage devices Quobyte can use into the container because it's not visible there otherwise.
Okay. I'm sure we may have more questions. Bjorn isn't going anywhere, so as you ask a question, as we go along, and feel free, Bjorn, to chirp in with any other questions. But thank you for that, and definitely everyone take a look. I just pushed out a link. Someone else had sent up the correct link to get the Quobyte try is www.quobyte.com/get-quobyte. So you can see that in the question stream. It was shared by someone else. If the get it isn't working for you. All right.
Sorry for that.
Thank you, Bjorn, and thanks for going through all that. I really appreciate it. It's a really interesting subject, and I think obviously with all the questions, people are really interested in this topic. Gu, I'm going to make you the presenter now. Can you have you received the ball, and can you share your screen?
Absolutely. Yep. Thank you.
Okay, I can see everything. Can you just make it full screen, and we should be good to go.
Great. Okay.
Excellent.
Well, first of all, thanks again for having me here today. I'm going to just show just a few quick slides to help set the stage, but I want to quickly get to a demo and showcase what we do, and hopefully we have enough time. I'll show you how this works with Rancher. Portworx is available in the Rancher catalog. Just to kind of give the 10,000-foot level, what Portworx is doing is, basically providing a storage solution for the modern data center for cloud-native applications. I think this, is obviously old news for everybody here on the call today, but at least helps me set the stage. People are, embracing DevOps and agility in the data center, and in part of that, moving away from fixed traditional infrastructure to more of a programmatic, easy to deploy, easy to manage, and scale infrastructure for that cloud-native experience. So whether people are building data centers based on commodity hardware, and I fully agree with what Bjorn was talking about with Quobyte, we see people who are building their own data centers do things with commodity servers or moving to public cloud. But in any event, you want to be able to treat your compute environment as disposable assets with a resilient software infrastructure stack. And so the modern components now include basically a software-defined storage layer, perhaps like Quobyte or Portworx, minimalistic OS with some sort of very intelligent orchestration and scheduling software like what you would get with the Rancher and Kubernetes. The problem that Portworx solves is that about infrastructure provisioning. As we see DevOps teams embrace technologies like Docker to package their applications and modern schedulers like Kubernetes to deploy their infrastructure, they are still stuck with providing infrastructure out of band. So this notion of being able to provision a LUN or a volume to a server and then carve out resources out of that to make your applications work, break the pattern in which you would like to deploy your applications. In an ideal world, you would like to live in a stateless world. In that case, you're at the peak of agility, but that's not the case. Unfortunately, we have state to deal with. What if we could make dealing with state as easy as dealing with stateless applications? And in order to do that, you need to start thinking about what the core problem is. The main issue here is the realization that applications don't really want volumes. As developers, we've kind of evolved to write our applications not monolithically anymore, but decompose it into sets of services that can communicate with each other over meaningful interfaces like a REST API or a SQL interface and so on. Sorry about that. So following along with that, you have to realize that the notion of a LUN or a volume or an NFS share, these were really designed for host operating systems or machines. And trying to take that and repurpose that and provision it to an application that's running in a container is an anti-pattern, and that's where people start really getting into a lot of problem and headaches with how do I deal with storage and stateful services running in containers. That's really the core of the issue. And so Portworx is designed a programmatic, elastic infrastructure solution, a storage service solution that it itself runs in a container. So this is what I want to demonstrate to you in a demo today, but Portworx deploying it is as easy as just doing a Docker run Portworx, and on each server that it runs, it aggregates the local underlying resources and basically creates a pool of meaningful storage services that can in turn be allocated to the rest of your application stack. So for example, if you're deploying your application stack with Rancher and you're using Kubernetes as your scheduling environment, you would simply deploy Portworx alongside the rest of your applications. So here's a fictitious application stack where I have Nginx talking over a well-known protocol to some Python code, which is talking over SQL to a MySQL database. Continuing along these lines, the MySQL database can programmatically subscribe to the type of infrastructure resources that it wants to Portworx and say, hey, I want a 4 terabyte volume, I want X amount of IOPS, I want snapshots at 12-hour granularity, and by the way, since I'm MySQL and don't handle my own replication, give me a highly replicated volume up to 3 servers or 4 servers or whatever. All of these things can be done on a per container basis, and it then becomes Portworx's job to ensure resiliency and the availability of the data services that MySQL needs, regardless of where it runs in the cluster. We'll talk a little bit about scale, but Portworx scales to thousands of nodes, hundreds of thousands of clients. We have been installed and in production at very large sites. Some of our customers are very large telcos. We have large financial institutions, people doing things like high-frequency trading against Portworx. So it's a very performant, stable, robust solution. I'm going to cut over to a couple of demos over here. I want to show you actually 3 demos, and I'll try and squeeze it very quickly. As questions come in, please send them over to Shannon. Shannon, please feel free to interrupt me. The first set of demo that I want to show you is...
Take your time, Goot. We've got plenty of time, too. Take your time. I think this is what everyone really wants to see is these demos. So let's go through them in some depth.
I'll just set the stage here. I want to show you a couple of things. If Portworx has done its job right, then you or your administrators are not really thinking about storage or how to manage drives and how to grow and provision capacity at all anymore. Portworx wants to provide a common denominator platform which will run on any cloud, any infrastructure, and not have you to deal with how do I hardwire an EBS volume to my app, or if I'm running on-prem, how do I take a vVol and provision it to an app? These are things that in 2017 you should not be thinking about. Portworx will allow you to automate the infrastructure. That's for your data center operators. More importantly, for your DevOps end users, they can programmatically consume the resources they want without having to be cognizant of where the application is running and how the storage will be delivered to it. To that end, I want to show you 3 demos. The first one actually is sort of an, like an anti-hero. It's an anti-demo for me because I want to show you the underlying plumbing on how Portworx runs. So for this, I will just show you some of the details under the hood. For example, I will start Portworx by doing a Docker run Portworx, and then I will allocate a volume using our Portworx CLI, which is called Pixie-Cuddle. But in reality, you're not doing this. You're just letting Rancher deploy Portworx on your servers, and your end users will allocate the storage services directly via Kubernetes, and Portworx is behind the scenes. But this demo showing you the plumbing will actually prompt you to ask me some interesting questions. So I'll flip over here. The premise here is I have 3 servers, which I'll refer to them by their last octet, 218, 219, and 220. These are running in AWS. These are EC2 instances with a couple of EBS volumes attached to them. First, what I want to show you is just to start Portworx, to do a Docker run Portworx, the first thing it does is it scans the local server resources. If it's running on-prem, it's going to detect your NVMEs, SSDs, and HDD tiers, create different pools. If it's running in AWS, it will detect the region and zone that the instance is running in, because our data placement and protection is region and zone aware. Then what it does is it looks for the EBS volume types, provision IOPS, instance local store, and so on. Finally, in this, sorry, not finally, but next thing that it happens in this is as I bring nodes up on 219 and 220, you will see how you can horizontally scale your cluster. Early on, there was a question to Will about scaling. We support auto scale groups. A very popular use case is to be able to scale your compute needs with on-demand services. So as you use ASG to scale your clusters up and down, Portworx will inline scale with your scaling groups. So with that, I'll just start Portworx on 218. At the end, I'll show you where you can get this and get your hands on the product. So here I'm running Portworx on the first node. You can see that it detected that there should be a 3-node cluster. There's roughly about 120 gigabytes on this node. There were 2 drives. Detected that they're both capable of caching. As I bring Portworx up on the other nodes, they will join the cluster, and you can see here the capacity keeps increasing to 300 and then half a terabyte. So like this, you can bring up as many instances as you want to scale the compute and capacity needs. Portworx will, and for trying to facilitate a converged solution. So in that, we like to run hyperconverged. So we work in conjunction with the scheduler, for example, Kubernetes, to place the compute nodes, for example, if you're running MySQL or a Cassandra, on a node where its data lives. Modern applications typically have been being written to scale out, and applications like Cassandra and so on will want to run on nodes where its data lives. Also, Portworx is application ring aware. So if you're running, for example, a Cassandra ring on Portworx, it will necessarily place the different Cassandra instances data on different racks and regions so that you can tolerate rack failures and things like that. So obviously when Portworx comes up, it detects which rack and which server it's on. So it does data center topology aware data placement. So now I have a 3-node cluster. Everything that you need to run Portworx, like our CLI, our integration with Docker, our integration with Kubernetes, our REST endpoint, everything runs within the container. There is nothing separate that you need to install, like a Rexray or something else like that. Here, I'm just showing you the different options you can do. When you create a volume, you can set the block size, replication factor, select a certain type of file system. We do support encryption. We support bring your own key encryption. So if you're using something like HashiCorp's Vault or Amazon's KMS, Portworx will integrate with that out of the box. We just basically use dmcrypt under the hood to do it, so there's virtually no overhead to turn on encryption at all. Everything that Portworx does is at container granularity. So in one extreme example, let's say you had just one EC2 instance and one EBS drive, you could have 3, 4, any number of containers running on it, each with different block sizes, each with different encryption keys. So it truly is providing container granular storage services. Here in this demo, I want to run MySQL, so I'll create a demo vol and set the replication factor to 3 because MySQL can't handle its own replication. There are some interesting use cases where people turn a replication on with Cassandra as well to get faster failover, and I can walk you through that. So I created a volume on 219 because we're truly clustered. Any volume you create can be used anywhere else in the cluster. There is no notion of a central metadata server, which is what lets us scale so well. I created a volume on 219. I will go ahead and do the manual Docker run on 220. Here I'm basically running MySQL. I passed it the volume. Again, Rancher will do this for you in a real environment, but if I did it through Rancher, you would be missing all the interesting things that are happening here. Now I have MySQL running. It doesn't see any of the underlying EBS volumes or storage devices. All it sees is the Portworx virtual volume. I'll connect to the MySQL instance, and what I want to do is create a database. I'll create a demo database. And now, when it's written, it goes to Portworx. I can go to back to 219, for instance, and what I'll do is I'll take a snapshot of it. So let's say, for instance, I wanted to test a database upgrade, and I can go to a development cluster, take a snapshot of it, and start a second parallel instance of MySQL on a different server. Obviously, what we expect to see is that demo database that I created in the first original MySQL instance. Now I'm running 2 instances of MySQL, one with the original and one with the snapshot. Just quickly go over here and verify that both the volumes are obviously in use. If I look at the CLI and list the volumes, both of them are in use. I'll connect to the snapshot, and if I list the databases, I expect to see the demo database there, and indeed I do. In this demo, I brought up 3 nodes to demonstrate horizontal scaling. Sometimes you may not want to bring up more instances, and you may simply be running out of capacity. You can, at that point, just throw another EBS volume in the pool. So here, I'll just add another drive, and you can see that that inserts itself in the pool, and the capacity where my mouse is increases from 0.5 terabyte to 560 gigs. So basically, we want to make all of the hassles you would have had with capacity management and storage and data just really brain dead. It shouldn't be a rocket science to manage that anymore. I did things by hand over here. Normally, you would just do this directly programmatically through Kubernetes this way. That same volume that I allocated can be instructed to be provided via this pod spec here. You can see I'm saying give me a volume of 4 terabytes, a certain class of service. Class of service maps to IOPS. I'll be talking a little bit about how we do IOPS enforcement in actually, maybe this is a good time to do it. Because we are actually providing the storage services, we are in the data path, we can do IOPS enforcement. You can have, for example, 3 different containers running on an EC2 instance, all receiving different I/O priorities. We support basically 3 levels: high, medium, low. Because we're software, obviously mileage varies based on the underlying hardware you provide, but the high, medium, low maps to different I/O priority levels. If you go to our doc site, all of this information that I'm talking about is documented on docs, that's docs.portworx.com. If you go there, you can go through how the I/O prioritization works. Just to kind of go along with that demo that I was just showing, I want to show you the power that your DevOps users have. What I showed here is basically the provisioning or the data center operator's experience. From an end user's perspective, the premise here is I have that MySQL application running, and I run out of space. So I want to show you what your end users can do with the beauty of Docker and modern scheduling software in Portworx. So here I do a database insert, and you can see here MySQL throws an error saying that the table test data is full. So I flip over and to another terminal, and if I see why, if I inspect the volume, again, I can do this through Docker directly, but through the Portworx CLI, you get a little bit more information. It's telling me a couple of interesting things. It's saying that this MySQL volume is replicated on these 3 nodes, 106, 105, and 101, but you only specified the volume to be 14 gigs, and you don't have any space left. So I can simply now, at this point, think about it from an operator's perspective. They have to figure out where that container was running, then they have to attach more storage to it, and then they have to figure out how they're going to provide that storage to the MySQL instance and rebalance it and so on. Here, all I have to do is just do pixie-cuddle volume resize and say make that 15 gigs. Because everything is thinly provisioned, nothing is statically allocated, I can just go back and try that database insert again, and this time that succeeds. So this really gives your end users that programmatic look and feel. This is what we mean by a cloud-native experience, and this is what brings agility to the table. Being able to schedule containers fluidly using Rancher and Kubernetes, not having to worry about where it's running, asking the underlying infrastructure stack programmatically to set your I/O priority levels, encryption levels, replication factors, and you have to have trust in your infrastructure stack that it will protect it across regions and zones, being rack aware and things like that. Shannon, how are we doing on questions and time? I'm just sort of being cognizant of the time limit we have and want to keep enough time for questions.
I agree. Yeah, there's a couple questions. Why don't we go to a couple of those right now, and we can kind of go through this. So the first question was from Grant. Emily Smith. He said, "Has Portworx tried running Oracle database in a container?" Do you want to talk about that?
Yeah, so I have heard of 1 or 2 customers doing that with Portworx. To be honest, I haven't talked to them directly. Databases, however, if we're talking about it generically, have been a very popular use case for us. We have a lot of our customers running Postgres has been a very popular database. MariaDB. We have a partnership with CrunchyDB, for instance. Those have been very popular use cases. By far, on the NoSQL side, Cassandra has been one of the more popular deployments. Performance-wise, that is one of the questions over here. We're typically within 3% of bare metal performance. Typically on the reads, because we're multi-sourcing data, we're actually accelerating the performance. Actually, this lets me talk a little bit about, I guess, actually, hopefully that was the question.
Yeah, I think so. I think that was the question, was sort of talking about different databases and how they work on there. There was another question that a couple different people were asking about, which was just to clarify. So is Portworx available in the catalog? Is it available for cattle as well as Kubernetes, or just Kubernetes right now? Can you just talk about what's available around Rancher? I think there's a question from Mikola on this.
Yes. So yes, Portworx is available in the catalog. I'm going to show you a quick demo on that just after this first set of questions. It's just a 1.5 minute demo. I'll show you how easy it is with Rancher to deploy Portworx. If Rancher really makes this bringing these things up, silly now. The Portworx has a native driver with Kubernetes as of 1.6. So if you get the 1.6 release, all the integration with Kubernetes is directly baked in. We are an in-tree driver. The Portworx works seamlessly with Kubernetes or Mesosphere, and even Swarm. So you have your choice of schedulers with Rancher. What was the other question, Shannon?
Right. No, I think those are the two. There's another one. Ethan asked. He said, "Is there a way to migrate data into Portworx besides copy/rsync?"
That's a great question. There is, and we provide data migration tools. Just a slight segue. If you remember back in the day, I don't know how many of you guys remember when VMware was taking off. One of the big tools that they had that actually made VMware successful was this thing called P2V, or physical to virtual. Well, long story short, similar sets of tools are needed, unfortunately, today to still be able to move people into this new way of computing. And we do have sets of tools that allow for import from either databases or legacy storage services into Portworx. One other thing I want to mention here is that, a lot of us at Portworx have been in storage for a long time, and the last thing people want to have is vendor lock-in. And so while we do import, Portworx doesn't enforce a proprietary data format. Everything we store is directly readable by Linux as is. Obviously, you don't get all the benefits that Portworx has if you took it out, but your data is yours in your format.
Great. And Peter Lee asked if all of the plugins are open source.
Yes, we are open core. I'll talk about that. So a major portion of our data path is open source. If you go to, I'll just quickly use this slide to go, plug some of these projects. But if you go to openstorage.org, you can find a majority of our control plane and integration with the schedulers. All of that is open source. You'll see this is what lets us really scale to thousands of servers. LCFS, you can use that. That's a lot of our data path is in there. LCFS, as it stands, is a great replacement for Device Mapper or OverlayFS. All of the problems that you would have had with it, sort of what's addressed over here. That's well articulated and documented here. If you go to github.com/portworx/pxdev, you can get the fully packaged our enterprise version to try it out.
Great, great. Why don't we keep going with the demos? I think there's a couple other questions, but let's keep going through those, and then we can cover the rest when you're finished up.
Absolutely. So just to show you the integration with Rancher, here what I'm going to do is just basically I'm going to show you how easy it is to bring up I guess in this demo I do a 12-node Rancher cluster. So I want to show you a little bit of the GUI here. Normally when you're using Portworx, you're doing things just programmatically. I'm creating a cluster, a Portworx cluster. When you create a Portworx cluster, you basically create, just like even with etcd, you would have a discovery token. I just created a token over here, which is what lets the Portworx nodes discover each other and form a cluster. You can obviously have multiple Portworx clusters running in your data center. How do they identify themselves and segregate themselves? It is by something called a cluster token, or it's a unique token. That's what I created over there in our UI. Here, all I'm doing is just basically setting my scale, and I'm telling Rancher I want a 9-node environment, and I'll pick my machine size and do some necessary setting changes to allow Docker to successfully run. Choose an AMI that basically AMI that we're comfortable with. And Portworx likes to run with the latest Docker version. We recommend 1.12 at least, so we'll pick the latest Docker version over here. We do support the Docker plugin v2 interface. You can see here we're in the catalog. So what I'm going to do is basically configure this catalog. There's just a very few entries that Portworx needs to get up and running. The most important one of which is that cluster token that I had created. So I'll just copy that and then plug that into the catalog. And by default, Portworx will take advantage of all the underlying EBS volumes that are not in use. We will never use a volume that you're using for your host OS or anything like that. If you want specific volumes, you can go ahead and do further customization, but that's really it. By just a few clicks, and this video was recorded in with real-time, no editing for speed or anything like that, but you'll let Rancher do its magic, install Docker, and at this point, I have a 9-node. I guess I had half a terabyte each on each server, but I have a 9-node compute environment with a few terabytes of storage. You can look at this in the Portworx UI that the nodes come in, and as Rancher is bringing them up, Portworx is seeing that the Portworx nodes are registering and joining, and voila, I have 9 nodes running. At this point, I can now go and use Kubernetes to deploy any stateful application I want. Don't have to care about where it's going to deploy it, where its services are being protected. But that's really, I think, what people are achieving when it comes with respect to agility and programmatic provisioning using Rancher, Portworx, Kubernetes, and things like that. Shannon?
Awesome, Gu. Thank you so much for that and for the demos, for talking through everything today. You know, I realize storage is a hard thing to demo, so I really appreciate you trying to get that working and showing us some of those videos. So there's a couple more questions. One of the questions came in from Grant. He asked if the demo videos are available on the Portworx website. I think you already showed that they were, that there were some in the docs. You had some demo videos in the docs. Do you want to just show people how to find those?
Absolutely. So please, if you can go to docs.portworx.com, hopefully you can see this, docs.portworx.com. And all the way at the bottom, there's a section called Video Demos, and we have a number of different video demos over there. You know, getting the doc site properly organized is always a challenge. If you have any feedback, please let us know. But really, the short is, if you want to just do a quick install and run, you can run directly with Docker. I think if you have Rancher, running it from within the Rancher catalog is obviously the easiest. And then the next thing you'd want to do is basically find out how to create storage volumes. We have here, you know, if you're somebody on the call earlier were asking about IOPS and class of service, we show you how Portworx does all of that enforcement on a per volume level. We have a lot of examples on how you can try it for yourself on Amazon over here. Yeah, so the videos are here, and there's a lot of documentation on how to get this working with different schedulers, and hopefully it's just not a science project.
Awesome. A couple questions that came in. This one is from Ronald Pagani. He said, for resizing, it appears to happen very quickly, assuming thin provisioning. Is there a point at which the user will experience a delay until capacity is available? Maybe a corner case if we resize from, say, 100 gigs to 10 terabytes.
Hey, Ronald, nice talking to you again. So if you're going from extremes like 100 to, let's say, 10 terabytes, obviously the storage may have to come from other nodes, and there may be a few milliseconds delay. But doing minor resizing is instantaneous because everything is thinly provisioned. If Portworx does have the ability to allocate storage on your behalf too, if we're running in a known cloud provider, and those include Azure, GCE, or Amazon, in which case we may have to, if you're making such drastic changes, we may have to allocate EBS volumes, and obviously there's a slight delay associated with that. But in the normal course of operation, it is just completely transparent, and because it's thin, it's instantaneous.
Awesome. This is a question from Paul. Paul said, is there storage class support for dynamic provisioning for Kubernetes? Do you want to take a hack at that?
Yes, the answer is yes, because we're a native driver that's fully supported.
Awesome. Ronnie asked, what's the price of the enterprise version? Same
For the
question everyone wants to know.
Yeah, it's so I can tell you what our pricing model is like. Please, you can contact us at just send us an email. You send it to me directly or support@portworx.com for custom pricing. But we're priced by server. There is a price per server in the cloud. We don't believe in capacity-based pricing. I think we've been jaded by the EMC era for too long. It is per node. If there's one model for a virtual machine or a cloud instance, and then if you're on-prem, there's a slightly different price because typically on-prem servers are slightly fatter and more capable. But for that price, please contact us. Also, if you're most of our, so like I mentioned, we're deployed at very large telcos. There we do data center site licenses.
Awesome. Thank you. There was another one that kind of falls along that line. Mikhail was asking, oh, I'm sorry, it was actually Ivan who was asking, does Portworx have a community edition? Is there something open source or community that people can either use or at least try?
Yes, we do. It's called PXDev. Again, if you go to our GitHub, let me just bring that up. If you go to this GitHub, github.com/portworx/pxdev. This is the community edition. Really, the only limit is that it's limited to 3 nodes, but all of the other features work. There's no other feature functionality limitation. This you can just get directly. It's on the Docker Hub. You can just do a Docker pull. Portworx pxdev. That also, actually, it's documented on our doc site. So if you go to install and run with Docker, this shows you how and where you can get it.
Excellent. This is a question from Mikhail Taina, and he asked, how does Portworx consistency work? How does PX handle storage nodes, Friday night failures? Does it automatically balance the data and maintain consistency, or do I have to maintain it manually when a node fails?
No, great question. You do not have to. Again, our whole goal is that we're making that just not a operational issue anymore. I think similar to what even Bjorn was talking about earlier, what Portworx does is the data is synchronously replicated on a quorum number of nodes asynchronously across a quorum. So if you had cross sites, so actually that allows me to bring this up. I wanted to show this. If we have the ability to monitor the Portworx deployments on customers' behalf. Some of them choose to. So you can see here there's about 1,000+ clusters that we're monitoring. A lot of the banks and financial institutions won't opt for this service and run air-gapped. To answer your question, what Portworx does is we'll synchronously place the data on other nodes, and the data placement is topology aware. And let's say you had a failure and a node were offline. Portworx is recording or journaling the data that needs to be replicated back to that node. There are two conditions that can happen, which is the node may never come back, in which case it's decommissioned. There's a permanent failure. And like Bjorn mentioned, this happens in large data centers. Typically once a month, people go in, collect all the servers that are dead, throw them away, or just send them back to service and put new nodes in. And Portworx will then replicate the data back to the healthy nodes. Portworx is automatically always doing this balancing of data, again, in a region rack aware basis. The other thing I want to mention over here, probably related to that, is we're application aware. So unlike technologies like Scale.io or Ceph, we're not sharding the data across all nodes in the cluster, which in turn have 2 problems. One is reliability goes down, actually, and your performance is bad. We are replicating the data to other nodes, but it is based on the application type. And again, things like Cassandra, there could be maybe 5 Cassandra nodes as part of a ring, so we're aware of all of that. And when a node comes back and we have to resync the data, Portworx will do the rebalancing, but again, without sharding.
Awesome. That's actually really a good description. So here's a question Ian wanted to have answered. He said, have you experienced customers that run storage across cloud providers? For example, running it at the same cluster across two obviously kind of close AWS or GCE zones?
We do. We have a few of those deployments, and let's talk about why that's the case. When people say across cloud providers, a lot of times people make it sound like it's a bit large distance, and typically it's not. We have a lot of customers doing this and I'll give you some practical reasons why people do this, but often the Google data center and Amazon data center are right next to each other, and most of the times they're both being operated by potentially the same company that are managing these different data centers. So for example, in Atlanta, if you go, there's a big area where all of these data centers are right next to each other, and a Google data center is right next across the parking lot from an Amazon data center. So to be able to replicate across that is not a big feat at all. Now, if you're wondering why do customers do this, so this is a little bit maybe, I know I'm on the record, but things like Microsoft has great account relationships that they've built over 20 years, and they're able to get much better pricing deals and they're really eager to move people off of Amazon. And it is the beauty of technologies like Docker and Rancher and Kubernetes and hopefully even Portworx that allow people to now be able to write to a common denominator platform, and moving from AWS back to Microsoft to get that huge cost benefit. We make this kind of application and data portability easy and allow that to happen. Also, some other reasons that people will do this is just maybe either regulatory, or they want to collaborate with another company and want to meet at a common ground, if that makes sense.
No, it makes perfect sense. I think that's why we started Rancher as well. It solves the same problem, so it makes a lot of sense. Okay, there was a question from Ayman Hussein. He said, will we always need a key from Portworx, so our environments always will be connected somehow with Portworx? I'm not sure I quite understand the question. Maybe you don't need a key from Portworx. When you buy Portworx and your data is yours. We have a hosted service called Lighthouse, which a lot of our customers choose to host with us. And that's simply for us to host the following things: the management interface, basically to give them a SaaS kind of experience for the manageability, and that's that you can see over here. And as we're upgrading the UI, you get the benefit of getting being up to date with the latest version. But we also provide this on-prem for no additional charge. So if you want to run Lighthouse on your own, it's just yet another container that you can run. I'm of the opinion that people want to manage their data, but not necessarily the control plane. So, depending on if you're a bank or a financial institution, you would probably just run Lighthouse on-prem, in which case we don't know what you're doing. There's no key or anything like that. Okay, couple more, 6 more questions or so here. We'll move through these quickly. Finney asked, if for some reason you over-provision storage, any danger to resizing downwards?
Oh, that's another good question. No, it's not, and we will tell. So we are really trying to help with that capacity planning. So if you're going to remove storage, we will rebalance the data and let you know when you can remove it. You can do things like once you create a volume, you can change the protection levels on the volumes if you want to do such kind of capacity rebalancing. A related question I get asked is sometimes an operator will want to, so they will know that there's a server that they want to take offline, and they can go to Portworx and say, I'm going to take this particular server offline, and we will show them all the volumes that could potentially get impacted, and we'll tell them where else their data is, and the operator can say, okay, no problem, I'm going to take it out anyway, and Portworx will just re-replicate the data to some other nodes.
Excellent. There's another question about the open source version. Does it also include the GUI? That was from Andre.
No. So no, Lighthouse is not included with PXDev. Yeah, it's. I think we may at some point, but currently not. Okay.
And then Tom asked, is there a way to have a shared file system between containers that using Portworx?
Yeah, so databases obviously you'd want to run with the volumes that I showed. We do have a shared file system or a shared namespace. So It comes with a slight metadata overhead, but it's very, very minimal. It's very convenient for file workloads, things like logging, or if you have WordPress, that's a common use case. This volume can be used, can be simultaneously mounted into multiple containers, even if they're running on different hosts, different servers, and even different regions.
Okay. Great. Another question. This one's from Brian. Is there any difference with the install process on the website versus the PXDev community cat stack?
No, there's no. So there were two install processes that I showed. One is just doing the Docker run directly. That's what's if you go to our docs.portworx.com and click on Run with Docker, that's what's documented there. If you deploy with Rancher, you're not even doing that. You're just clicking the template and providing a cluster ID or a token and then running from there.
Awesome. Ben said, sorry if this was answered before, but does Portworx support erasure encoding or just traditional file replication?
Well, Portworx is replication. Currently, we have erasure encoding on the roadmap. Today, it is block level replication.
Okay. Diego Braga says, do you support hybrid clusters made out of 2 hosts, 1 virtual and 1 physical, with different storage attached? Man,
we do.
We're getting good ones.
Yeah, the answer is yes, and we do have a lot of people running that. We see a lot of people straddling their clusters from on-prem to public cloud. We're working with, for example, a very large cruise liner where they have VMware on their ships. And on their data centers, it's all in AWS, and our clusters straddle that. And as the ships come in and dock, Portworx will re-replicate the data back to their data center. So the clusters can get detached and reattached.
Awesome. There's another question from Ben. He said, what about unexpected outages or spot instances with 2-minute warning? Will the downward resize still work?
Yes, it will, because what Portworx does is, and so now this is for AWS. So with ASG, it's a great question. So when you're resizing, instances get terminated. What Portworx does is it embodies the persona or its identity inside the EBS volumes. So when the instances get terminated, the EBS volumes get re-relinquished back into a pool. The remaining Portworx nodes know how to go in and grab them and reattach them, so the storage is still available.
Awesome. There was a question from Brian. He said, is there a Rancher catalog? Is the Rancher catalog cover the enterprise version of Portworx for cattle or the community version?
It's the community version. We do have the enterprise. We can make the enterprise version available for Rancher as well. If you just contact us, we'll show you how we can do that.
Awesome. Ethan said, is host affinity how Portworx knows the apps in Rancher cattle, or is the app awareness Kubernetes only?
I want to say the app awareness is Kubernetes only. What we do is we place constraints for the scheduler. So when you start Portworx up, it knows about either Kubernetes Swarm or Mesosphere when it comes to scheduling placements. So I think it's going to just basically tell Kubernetes which node to run the job on. Or rather the preferred nodes to run it on. And keep in mind that Kubernetes could always override this decision for other reasons and run the job somewhere else. And in which case, its data is still accessible. Portworx is able to, because we're a clustered network device, but it'll fetch it over the network. A related question I get asked is, you can also, maybe even back to the previous question around hybrid deployments, you can have compute-only instances and have your storage-heavy nodes somewhere else. And Portworx can run on the compute-only instances which have no local storage, and your applications can also still be running there, and Portworx can still provide the virtual volumes there.
Great. Neil Arutsky said, how are DB schema changes coordinated vis-a-vis replication?
We're at block level, so we're not aware of that layer. So the application and its schema are sitting on top of us. So if we're replicating data and you expect to consume the volume by another database, maybe perhaps of a different version, that's an app level or a DB admin level task.
Excellent. Okay. Looks like 2 more questions. Andre said, can I replicate async 2 clusters over a WAN connection?
Yes, we support async replication. By default, we will if we detect that the, I don't know the exact tolerance limit. I don't know if it's 50 or 100 milliseconds, but that goes to async replication. And by default,
Okay,
we put outside quorum number of nodes across the other side of the WAN.
And then Jeffrey had just asked, what are the latency requirements for replication? We just said 50 milliseconds.
Yeah, we will replicate. So if you force us to and say, I put a PX node on the East Coast and another node on the West Coast, and I want synchronous replication, we'll do it. It's up to you and your applications if they can tolerate that latency. But we will, we can, and some applications will run that way.
One more question. Ben Emmons said, can you scale to a petabyte data lake?
We have two types of customers actually. One camp where they have are scaling in a higher number of nodes, thousands of nodes. We have a genomics database. Actually, there's a public case study on it. It's called TGen, where they have each data set is in the tens of or 20s of terabytes, and they're over a few petabytes.
Excellent. All right, Gu, I think we've covered all the questions. Last one is a good one. Brian just said, what's the best email to contact you to ask more questions?
Sure. My email address is gou@portworx.com. That's portworx.com. Just gou@portworx.com.
I just put that in the chat window, so everyone should have that. Excellent, excellent, excellent. Well, thank you, Gu, for the excellent demos and the discussion and answering so many great questions. Thank you, everyone, for all of those excellent questions. Okay, let's go through now and we're just going to go through the last couple things we always go through, which is to talk about the most recent releases and the upcoming releases on Rancher, and we always get lots of questions during this stage. So I'm just going to pull up my slides here and share them. And feel free to answer any questions that, feel free to ask any questions that may or may not have already been answered as we go. So, Will, are you still on the call?
Yep, I am.
All right, so we're just going to chat really quickly. For those of you who don't know, we released Rancher 1.5 on March 3rd. Will, do you just want to kind of quickly touch on some of the things that were in that release, some of the new features and fixes and enhancements that went out in the 1.5 release?
Sure. I think I'll go through a couple of these ones. The big ones that we added, actually 1.4, 1.5 are kind of related because they have a couple of features that are introduced on 1.4, and we added a couple more 1.5. Specifically, one is network policies. So we actually introduced this in 1.4. And 1.4 essentially within an environment will allow you to configure or set network policies. For example, you can say, currently today, by default, all containers, all servers can talk to each other as long as they belong to the same environment. So one of the things we added for network policy in 1.4 is the ability to say, well, deny all, no one can talk to each other, at least certainly at a stack level. With 1.5, we extended that by saying now you can control that by saying no services can talk to each other by default, even if they belong to the same stacks. But we also give you an option to add links, which will then allow certain, you can now link services, which means that we'll open up the network policy to allow you to communicate. So that's one of the features that we added. The other thing we did was webhooks. We introduced in 1.4 where we will let you generate webhooks specifically to scale up and down services. 1.5, we added two more. One is to scale up and down host, and the other one is be able to update an existing service specifically through Docker Hub. So you can add this webhook to your Docker Hub so that when you update an image in Docker Hub, it'll automatically update the service using that image directly in Rancher. So that's the other thing we added in 1.5. A couple other things we did, we have a new feature called API Interceptor. This basically it does a couple of things. The primary thing is to give you a pre and post hook to every API call. So you could, for example, pre-hooks could be, you can add your own policies on, what you would want the API call to Rancher to be. You can even modify the JSON request before finally sending the API call into Rancher itself. And then, of course, we give you post hooks as well. So after every API call, if you wish to do something else, you can add in your post hooks for those API requests. So API Interceptor is another thing that we added. One of the improvements that we did add, so for catalog, it says templating support for catalog items. Essentially, we're going to give you some if, then, else logic in the catalog templates that we support today. We had variable interpolation in the past where you can substitute variables, but now we give you some if, then, else logic that you can put in there as well. So that's templating support. For metadata, it's actually going to be broken in a couple of phases. Phase 1, we just did in 1.5. So one of the biggest thing for performance at scale was metadata. The way it worked before was that we had a metadata server in we would add one in every single Rancher host. And another problem that we did was every time there's an update to metadata, we would push the full updated metadata scheme to essentially every single host that's out there today. So you can imagine more hosts, the more containers you add, it's going to slow down whenever you launch new containers. So one of the things that we made for 1.5 was to, number one, we did some caching things on Rancher server side, so we made that faster. Second of all, the data we send there is not the full thing. I mean, we do send a lot of data, but the data footprint that we send is much smaller now. Now, phase 2 improvements we're going to do 1.7 and beyond. 1.6 we probably won't have time to do it, but of course the biggest thing would be just send it to a single metadata server, rather than all, and also to further reduce that data footprint that we send. Hopefully, just the delta, not the whole thing. So those are improvements that we want to do 1.7 and beyond. And of course, last thing is the Portainer UI we added for the Swarm UI. We just integrate with our Swarm the Swarm kit option that we have right now today. Next slide, Shannon.
There was a couple questions that came up before we jump off.
Yeah.
Mikhail asked, he said, can you restrict access to Rancher services like the Rancher metadata service using the network controls?
I guess theoretically, no, because specific to metadata, that one we don't have it today. We can certainly add that, but it doesn't work in the network policy. Actually, it's a good question. I think with the services, we may do that, but the only reason why I hesitate to say that is because we actually apply a link local IP, and we kind of do some tricks there to do this. So what I meant by network policy to restrict access is really our restricting access using our Rancher managed IP, the 1042 IP address space. I don't know for certain whether this will affect that or not when you disable the policy at the service level. It might, but again, we do some tricks with link local, so that's why I'm hesitant to say whether it will actually disable that or not. And the second problem is if you disable that, a lot of Rancher servers would start failing. So I don't believe that is disabled.
Okay. There's another question Connor asked. He said, can we do network policy stack links to allow two stacks to talk to each other?
I believe so, except the link part. So how you want to, at a stack level, right now today, we don't have a UI to allow you to do that specifically because link is actually on a service level, not at a stack level. But I think you might be able to do that on the JSON. You can actually do it via an API call. I don't think that's in the UI today to do between stacks specifically, but services definitely yes, because actually there's two ways to do service links. It's one is Docker links, or the one you can actually add as a label to do this.
Excellent. There was a question from Michael. He asked about the API interceptor. Can you request specific API actions like allowing view logs but not allowing launching a shell to a container, for instance?
Yes, if you want to add your own rule. So today that's more of an RBAC solution that we're actually looking into try to do something in the 1.7 plus time frame, or at least parts of it. But yes, you could theoretically get around this by intercepting a specific API call, and again, you can apply whatever policy you want. You can say for this user, you simply just cannot access, just deny the request outright, and it won't even go to the Rancher server to fulfill the request. So yes, technically you could do that today.
There's one last question. It's a little more of a general question, but Chris asked, he said, are there recipes available for host scaling based on monitoring solutions? For example, using internal Rancher monitoring or Prometheus out there to automate the scaling of hosts?
We have integrated specific webhooks with Prometheus. I did a meetup a couple months back that kind of showcased this. We are looking to integrate something, either it's Prometheus, Sysdig, or any of these other monitoring solutions out there, but we don't have one right now. I think Bill my lead DevOps engineer is looking to come up with one.
Excellent. There's another question which said, is there a way with webhooks to finish the upgrade automatically?
No. The reason why I guess we could always put that option there. The reason why is we wanted you to at least test to make sure that's why it's two separate calls. But we could actually build that into the service upgrade itself, though. So it's not too hard. We can actually add an option that says automatically update regardless of whatever happens. So it's certainly something we can add, but it's not there right now.
All right. I just jumped to the last slide. But,
okay.
You want to just talk a little about now Rancher 1.6, which is coming in late April?
Yeah. So with 1.6, so usually we have month to month. We try to stick to month to month Rancher releases. It's shorter. It gives us a way for you guys to play with the features a lot sooner. But specifically for 1.6, we should have been shipped end of March. We're pushing to late end of April simply because Rancher is going to be. One is we're at KubeCon, the other thing we're going to be at DockerCon, so we have some things planned for us, and engineering teams work on that. So the 1.6 release won't be as big. I mean, it looks kind of big here, but its features have been working for a while. Let's go through it briefly. The one thing we're doing is, so catalog enhancement, we kind of already had this in 1.5, I just never talked about this, but right now catalog is more of a global thing where you set up a catalog service. Right now we have the community one by default, but if you have your own private catalog with your own GitHub repos attached to it, it's actually available to all environments. So we have already added the ability to add this on a per environment level. It's just not available to be configured through the UI. So through the API will be made available. We'll make sure that kind of works, and at least from an API perspective in 1.6 where you use if you want to configure it before we add the UI on top of it. HA product enhancement, I think specifically a couple of features we want to do with this. For sure, what we're going to do is the ability to mount certificates from a volume rather than the way we do it today where you have to add the certificate through a UI and then somehow we copy it there. I think we'll give you a way to specify volume where the certificates will be available. This is most notably used in conjunction with something like Let's Encrypt. So that's one. The other enhancement we're planning to do is more like the drain, where we'll allow you to drain connections before we actually shut down the containers, things like that. So those are a couple of the enhancements that we want to add for 1.6. EBS and certainly EBS for sure. We want to certify that. Right now it's experimental, but we're going to do more testing to make sure that works. I know some of you asked a few things like adding encryption, things like that. We'll look into it, but I think our first thing we want to make sure is what we currently have is something we can support as part of our SLA. Scheduling enhancement, I think we're adding one additional rule to cattle specifically, where you can now schedule containers evenly across a pool of hosts. This is primarily, the use case is where you can have a set of hosts in zone A and a set of hosts in zone B, and although Rancher today we allow you to specifically target those hosts, it doesn't actually evenly distribute this across both zones. So a lot of users and customers want the ability to target specific hosts, but also to evenly distribute it across different zones. So that's one of the scheduling improvements we're going to add. And then lastly, of course, with Kubernetes, 1.6 with Docker 1.13 support, or at least 17.03, the new Docker way of naming their CE platform. We want to support that with 1.6. Following this, 1.7.1.8 should continue the normal monthly release. I think that's
okay.
it.
I think we've covered everything. A couple of quick last things that came in. Michael just was asking if there's any work on the roadmap to simplify troubleshooting, such as improving master server logs with more detail and less Java stack traces. Anything you can share there?
Yeah, we actually we've actually I have one of our engineers wrote some service that actually reads not even just the Rancher server, but also specifically our network containers, metadata server. When those things fail, it's a little hard to collect the logs for that and to notify something has failed. It's something's in the works. Short answer is there is something in the works. We're trying to figure out how we can make that as part of a default system service, so we can provide those logs, whether it be Rancher server log, agent logs, whatever. So those are things that first we want to try to monitor that, and also give you a way to alert you somehow, whether it's email, SMTP, whatever, somewhere where you can configure that or post it to to some syslog for you so that you'll know, something like that. So that is something that we are working right now already with one of my engineers.
Okay. Another question that came in was from Brian. He said it was a scheduler question. Does the scheduler restrict over allocation of memory with containers? Will it stop scheduling containers to a host if there is little memory?
Yeah, we do already have that today. That actually was shipped, I can't remember, 1.3.1.4. We do allow you to we do allow you to specify, or at least you can go to the host and at least make sure that it has the CPU memory requirements. And when you launch a container, as long as you specify that as options, we'll make sure we'll schedule accordingly and not over provision.
Okay. I think we covered that in a meetup as well a couple weeks ago. A couple months ago, I mean. Final question was from Jerry. Jerry said, when using Cattle, does Rancher have plugins that support different service upgrade methods? A Rancher scenario, we're performing rolling upgrades of a service which requires a specific host port for each instance. I can't do blue-green due to the port constraints, and if the rolling upgrades fail, then I have to babysit and cancel mid-upgrade. So any programmability or anything you can talk to there on the upgrade side, Will?
Sorry, the question is when you do a rolling upgrade, because of port, you may fail because you don't have enough. I guess the problem is you don't have enough hosts to do that. That's a good question. I would have to. I think this is probably a question we might have to take because I'm not 100% sure. I mean, I see your point. I just can't remember how we deal with the case where you don't have enough ports available to do an upgrade like that. I think specifically, because I know in Rancher today, if you stop it, it doesn't actually remove. I mean, it won't let you schedule because we still believe that the container can be restarted, so that port isn't deallocated, so to speak. So if you have enough hosts, I guess there wouldn't be a problem. But if you don't have enough, I assume that's what the problem lies in. I don't know if we have that today. I think that's a better question for Elena. Unfortunately, she's not here right now, but we could probably table back. I don't know, Shannon, if there's another way to provide the answers at another time.
Yeah, Jerry, if you'd like, just feel free to email, Shannon at rancher.com, and we'll see if we can get you an answer on that one, or, if we can. Last question was from Chris. He said, is there any support for GPU nodes, or is it coming, or any update on GPU nodes?
GPU nodes?
Yeah.
I have not looked at it specifically ourselves, but if it's something that Docker can support, I don't know why we wouldn't support that.
Okay.
Yeah.
All right, everyone. I want to just kind of wrap up by, if you haven't already, please, download Rancher OS, download the demos we saw today from Portworx and Quobyte. There's all this amazing software that's available. You can use it. You can try it. You can test it, and it's amazing how fast these communities are growing. So feel free to jump in, get involved. We're always looking for people to help. Even better, if you haven't already, try.rancher.com is out there. It's super easy. It's free. You can use it as long as you like. It's not production grade, but otherwise you get a hosted Rancher deployment that you can run as much and as long as you like to get a feel for the kind of the end user experience or the user experience of the product. So feel free to sign up for an account if you haven't already. And if you need a little bit more sort of starting training and you're kind of getting going, there we run free monthly trainings. You just go to rancher.com/training. They're live. They're once a month. They're very similar to this, but they start at the beginning and we go through and just explain everything. So great for anyone on your team that's trying to pick this up, or anyone who's trying to just get the basics of deploying applications in, Cattle or Kubernetes or Mesos or Swarm. Finally, I just want to say thanks to everyone for attending. We have almost 400 people here today, which is one of the biggest I think we've seen so far. So it's amazing. I think we had 397. So thank you all for attending. A special thanks to Will and Gu and Bjorn for the excellent presentations and for answering so many questions. This is why we do these as meetups. It's so exciting to see so many people get involved, so many different people asking questions. Thank you so much for everyone who attended. We'll be back next month with a new topic and more of the same. So please join us again next month. Thanks, everyone.